Now, my dear students, we can see the question number 21. Here, which of the following is the correct order of dipole moment? Here, we can see the correct order of dipole moment. You can see the correct order of dipole moment when dipole moment is greater or lower. So, you can see here, lone pair of electrons are maximum percent, means dipole moment is more. So, A, B, C is the answer. D is not, because there 0 dipole moment is percent. Now, we can see here NF3, NF3, my dear students, NF3, NF3 dipole moment is 0, because NF3, these two fluorine atoms repel the or two fluorine atoms this F and F, these two fluorine atoms are cancelled the dipole moment with each other, and third fluorine atom cancel the dipole moment of lone pair of electrons which are present above. This one and this one, both are cancelled with each other, and this fluorine atom, this dipole moment, and here this dipole moment. So, my dear students, these are cancelled with each other. So, NF3 have 0 dipole moment, so you cannot go to this NF3. So, you can go the question number 21, option is C. Option is not C, option is B. Option is B, because in B ammonia is greater than NF3. NF3 have 0 dipole moment. So, you can go to the option B. Now, my dear students, we can go to the question number 22. The species having bond angles of 120 degree is. Here, my dear students, you can see the hybridization ClF3 and Cl3, BCl3 and PS3. You can get the, in this hybridization, sp2 hybridization is present, and sp2 hybridization trigonal planar structure is present, and in this structure hybridization is angle is 120 degree, but lone pair of electrons equal to 0. This lone pair of electrons change these angles due to the repulsion. So, my dear friends, you can go that molecule in which lone pair of electrons 0. So, you can question number 22, you can go the option C, because in C no lone pair of electrons is present, in boron 0 lone pair of electrons is present. For this nitrogen, 1 lone pair electron present, in phosphorus 1, in chlorine you can see that 3 lone pair electrons are present. So, here my dear students, here no lone pair electron present in this boron, so answer is C. Now, my dear students, when we go to the question number 23, here in question number 23 we can see the CH4, ammonia and water, which of the given statement is false? The HOH bond angle in water is larger than the CH4 bond angle in methane. My dear students, when you can see the bond angles, here methane molecule tetrahedral, sp3 hybridization, bond angle is 109 degree, 28 minutes. Here in ammonia molecules, it is a pyramidal in shape, angle is here approximately 107. In water molecule, my dear students, angle is 105, approximately 105. So, my dear students, angle of water is lowest. Here you can see the this statement is false. So, you can go to the answer D, my dear students, because bond angle in water is larger than this methane. It is a wrong statement. Bond angle is this. So, question number 23, you can go the answer D. Now, my dear students, we can see the question number 24th. Which of the following has the maximum dipole moment? Here you can see the question number 24, the answer is C, because here this structure is a pyramidal, and in ammonia you can see the pyramidal structure, means nitrogen, lone pair of electrons, these hydrogen atoms are present. So, this pyramidal structure, my dear students, dipole moment is maximum in this structure due to this repulsion of lone pair and bond pair of electrons. In methane, no lone pair is present. Here carbon dioxide linear structure is present. In NF3, you can see the NF3, this dipole moment is 0 because this fluoride attract the bond pair of electrons in opposite side to that of nitrogen. So, my dear students, these are the cancelled with each other. So, answer is your 24C answer is correct answer, and this is called pyramidal in shape. Pyramidal. It is a pyramidal in shape. Now, question number 24, you can see the answer is C. This question is also asked in 2014. Now, my dear students, we can go to the question number 25th. In question number 25th, the correct order of increasing bond length of CH, CO, C single bond C and C double bond C. Here, my dear friends, you can see the bond length of this C single bond C, C single bond O, it's a greater than this and this is greater than this. Here, my dear friends, bond length of this carbon double bond carbon is greater than carbon single bond hydrogen. So, you go the answer A, question number 25th, answer is A. This question is also asked in 2011. Bond length of CC is greater than CO, CO is greater than double bond is greater than C single bond H. Now, my dear students, you can go to the question number 26. Which of the following structure is the most preferred and has of the lowest energy for SO3 molecules? Here, my dear students, you can see those molecule is the most stable structure in which most covalent bond are maximum. You can see the maximum covalent bonds are present. Those structure is most stable in which maximum covalent bonds are present. So, my dear friends, 2 plus 2 plus 2, 6 covalent bonds are present. That is why it is a most stable structure and lowest energy structure. Now, we can go to the question number 27. Here, my dear friends, you can see the correct of increasing bond angle in the following triatomic species is. Here, you can draw the structure of the molecules. Now, we can see the NO2 minus and get the lone pair electrons, coordinate bond O and double bond O. You can see here angle is 115 degree angle present. Now, we can go to the NO2 molecules. In NO2 molecules, you can here 1 minus charge, here in this 1 negative charge is present. In NO2 molecules, no negative charge is present. So, repulsion is 115. Now, NO2 molecules, you can repulsion is less. So, you can get the 134 degree angle. Now, my dear students, here this is the NO2 plus 1. NO2 plus 1 electrons are go, these electrons, outermost electrons are removed. So, this repulsion is less and you can get this structure, and in this structure you can get the 180 degree angle. So, my dear students, highest angle is present, this NO2 plus, then you can go to NO2 plus and NO2. So, my dear students, you can go to the question number 27, that is the answer is D, increasing order. This question is also asked in 2008. Now, my dear students, we can go to the question number 28. The correct order of CO bond length among CO, CO3 minus 2 and CO2 is. Here, my dear students, we can see the bond length. Here, in single bond length is maximum, then double bond, then triple bond. So, my dear students, in this question number 28, you can get the carbonate ions have the maximum bond length, because in carbonate ion, when you can draw the structure of carbonate minus ions. Here this is the CO, O and O. One minus charge, second minus charge. So, my dear student, this is the structure of carbonate minus ions. Here single bond is present, but in CO2 you can see double bonds are present. So, bond length is lower than single bond. Now, you can see here carbon monoxide, here triple bonds are present. So, bond length are very less. So, my dear students, you can go to the C option, question number 28, answer is C, and this question is also asked in 2007 NEET exams. Now, we can see here question number 29. This question is also asked in NEET 2006 exam. The electronegativity difference between nitrogen and phosphorus is greater than that between nitrogen and hydrogen. Here the dipole moment of ammonia NH3 1.5D is larger than that of NF 3.2D. This is because, my dear students, question number 29, you can go to the answer C, because in ammonia the atomic dipole and bond dipoles are in the same direction, while in NF3 these are in opposite direction. We can see the structure of NF3 in previous questions. So, you can easily solve this question. Question number 29, answer is C. Now, we can go to the question number 30. The correct order in which the O single bond O bond length increases in the following is. Here, my dear students, this question is asked in first of all 1995, and then this question is asked in 2005. Now, my dear students, you can see this question number 30. Bond length, you can see the bond length of H2O2, H2O2, and H2O2 structure is a open like structure, you know, open book, O and O is present, here H and H. So, my dear students, bond length is maximum in O bond length in H2O2. So, you can find out the structure and you can see the structure of H2O2, then you can find out the bond length is maximum, and this bond length is 1.48 angstrom. Now, we can see the ozone molecule. In ozone molecule, bond length of O and O that equal to 1.28 angstrom. Now, we can O2 molecule, in O2 molecule double bond is present. So, bond length is minimum, that is 1.21 angstrom. So, my dear students, you can go the answer D, because in D option H2O2 have highest bond length between O and O bond. These are the structure 1, 2 and 3. Now, we can go to the question number 31. The correct sequence of increasing covalent character is represented by here covalent character. He is asked the covalent character. Now, we can see here concept. Smallest, smaller the size of cation, smaller the size of cation, greater, smaller the size of cation and greater the size of anion, and greater the size of anion. That form the covalent character. So, my dear students, you can see the all are halides. So, you can see the cation size is beryllium plus 2, Na plus 1 and lithium plus 1. Cationic size is less in beryllium plus 2, then lithium and then Na. So, you can go the answer C. Here beryllium plus 2 is the smallest size. So, I have the more covalent character than lithium and then sodium. So, these are the concept. You must be learn this concept, and according to this concept, you can solve the questions which are asked in your exams. Now, my dear students, we can see the question number 32. Which of the following would have a permanent dipole moment? Permanent dipole moment. My dear students, here you can see the question number 32, answer is B. In B, you can get the permanent dipole moment because in B, SF4 molecule is present 1, 2, 3 and 4, and here 1 lone pair electrons are also present. So, my dear students, due to presence of these lone pair electrons, permanent dipole moment is shown by SF4 molecule. It is due to the structure. So, my dear students, you can go the question number 32, B option, permanent dipole moment, because these are not cancelled with each other due to this geometry and structure of SF4 molecule. Now, we can go to the question number 33. Water is dipolar whereas BF2 is not. It is because H2 is dipolar but BF2 is not. My dear students, you can go to the question number 33. Water structure is V shape. Here you can see the lone pair electrons here. So, it is also called angular structure, and structure of beryllium difluoride is this type of structure and it is called linear. So, my dear students, this is a linear structure, and due to this linear structure, these are the fluorine atoms cancelled, the dipole moment with each other, but this is not cancelled. So, you can go to the option D. 33, question number 33, you can go to the option D. Water is angular and BF2 is a linear. It is an angular structure. You can see here, this is the angular structure. You can go to the question number 34. Which of the following molecules does not possess a permanent dipole moment? Here, my dear students, question number 34, you can go to the option A because you can make the structure. Carbon disulfide structure is this one. It is a linear structure, and so here these are the cancelled, dipoles are cancelled with each other. So, no dipole moment is present. So, dipole moment is equal to 0. Permanent dipole moment is 0. So, my dear students, you can go the question number 34, CS2. Now, my dear students, we can see the question number 35. The table shown below gives the bond dissociation energies E dissociation for a single covalent bonds of carbon atoms with elements A, B, C and D. Which elements has the smallest atom? My dear students, he want the bond dissociation energy BDE. Bond dissociation energy is highest for that element, or that element highest in which size is smallest. So, you can see here 485 is the highest E dissociation energy, it means it says smallest size. So, C and D, C is a common carbon, A, B, C, D means this element is a, D element is the smallest in size. So, it is the smallest atom. For example, you can get the CF. In CF molecule, you can get the high bond dissociation enthalpy. So, my dear students, you can go the option B. Question number 35, answer is B. Now, we can go to the question number 36. Its strongest bond is in between, but the concept, my dear students, concept is that largest cation, largest size of cation means, for example, if you get the sodium, potassium, rubidium and cesium, the largest size of cesium and smallest size of an ion. For example, fluorine, chlorine, bromine and iodine. Or you can also say that smallest size or high electronegativity. This forms the strongest bond. So my dear friends, you can see here the CSF, cesium fluoride, is formed the strongest bond with compared to NaCl. So my dear friends, you go the question number 36, you go the answer A. Question number 36, you can go the answer A. Question number 36, you can go the answer A because cesium is a larger in size while fluoride is a small in size. Now we can go to the question number 37. Which of the following bonds will be most polar? In which, my dear students, what is the concept? High electronegativity, difference makes the polarity more. So my dear students, here you can see the NF molecule. Here nitrogen and fluorine, electronegativity is maximum. So your answer is C. Question number 37, answer is C. Now we can go to the question number 38. In the structure of ClF3, the number of lone pair electrons central atom chlorine is. My dear students, you can calculate by the trick. Here in chlorine, total valence electron that equal to 7. Here 3 fluorine from the bonds that equal to 3 minus 3, and remaining you have 4 electrons are present. So 4 electrons is divided by 2, that equal to, you get the 2 lone pair electrons. And ClF3 molecules, you can get the 2 lone pair electrons. We can calculate in this way. Bond pairs are minus ClF3, 3 bonds are formed with fluorine atom, 1, 2, 3. And when 3 bonds are formed, valence electron is 7 minus 3. So you can get the 4 electrons divided by 2 because in one bond or one pair, here 2 electrons are present. So you can get the 2 lone pair of electrons. Now my dear students, we can go to the question number 39. Here predict the correct order. It's a best pair theory, my dear students, valence shell electron pair repulsion theory. And this best pair theory, my dear students, we can see here repulsion between lone pair is greater than lone pair bond pair, and repulsion between lone pair bond pair is greater than bond pair bond pair. So my dear students, you can see here where is a lone pair bond pair, bond pair bond pair, lone pair bond pair and bond pair bond pair. Yes, you can go to the answer C. A lone pair, repulsion between lone pair is greater than lone pair bond pair, and it is greater than bond pair and bond pair. This is best pair theory. So your answer is C. Now my dear students, we can go to the question number 40. Which of the following species contains 3 bond pairs and 1 lone pair around the central atom? Here my dear students, you can get the 1 lone pair, but in water you can get the 2 lone pair. So it's not answer. BF3 no lone pair is present, not answer. NH2 minus and PCl3. Here in phosphorus, valence electron is phosphorus is that equal to 5. Here 3 bonds are present with 3 ICl. So minus 3, you can get 2 electrons. 2 electrons means 2 by 2, you can get 1 lone pair of electrons. So my dear students, your answer is D, because here you can get the Cl3 bond pair. Question number 40, answer is D. Now we can go to the question number 41. Which of the following is not correct statement? Multiple bonds are always shorter than corresponding single one. Correct statement. The electron deficient molecule is Lewis acid. Yes. BCl3. The canonical structure have no real existence. Yes. Resonance hybrid is a real existence. So answer is D. Every AB5 molecules does not in fact have square pyramidal structure. When you can see the AB5 molecule structure, number 1 is the planar pyramidal, number second one is the square pyramidal, and number third one is the trigonal bipyramidal. So 1, 2 and 3. These three structures are present in AB5 molecules. Planar pyramidal in this type of structure. This is called planar pyramidal, square pyramidal, this type of structure, B, P, it is called square pyramidal, A, B, it is called planar pyramidal and trigonal pyramidal, A, B, 3 and 4 and 5. So my dear students, it is called trigonal bipyramidal. Question number 41, answer is D. Now we can go to the question number 42. Which of the following is not isostructural with SiCl4? Here we can see the answer is SCl4. Why? Because here distorted structure is present, so it is not a isostructural. Distorted tetrahedral structure is present. So my dear students, you can see here not isostructural with SiCl4, that is SCl4. Question number 42. Now we can see the question number 43. In which of the following molecules all the bonds are not equal? All the bonds are not equal. So my dear students, you can see the lone pair electrons and bond pair electrons. Here this answer is B. You can see the 3 fluorine is attached with this lone pair electron ClF3. So here you can see those lone pair electrons nearer to this bond pair of electrons, these bonds are not equal. So my dear students, here two axial bonds, this and this one, have the angles 1.70 angstrom, but in this angle 1.60 angstrom. So this axial angle bond angle is 1.70 longest, and this is the equatorial. So my dear students, angle is a 1.60. So your answer is B. B option is the correct answer. Question number 43. Now we can see the question number 44. Which of the following molecules has trigonal planar geometry? A trigonal planar geometry is the answer is A, because there are no lone pair electrons present here. 1, 1, and here these are 3 lone pair vectors present, so geometry is changed. Here no lone pair vectors present, so geometry is trigonal planar. Now my dear students, we can go to the question number 45. In a regular octahedral molecules, mx6 the number of x bonds at 180 degree. You can form the structure mx6. This is M. Here you have the 1, 2, 3, 4, this is a 5, and this is 6. And now we can see the 180 degree angle. Here this is 180 degree angle, 1. Here this is a 180 degree angle, 2. And here this is the 180 degree angle. This is 3. So my dear students, you can see the 3 180 degree angle bonds are present, and these bonds are between x, here x, m and x, m and x. Here x, m and x. So my dear students, answer is your 3. So my dear students, complete this chapter chemical bonding, and in this chemical bonding we solved the questions which are asked in 30 years in NEET exams, and you can see the hybridization, geometry, dipole moment and structures in this type of questions are coming. So my dear students, I hope you learn and remember and revision of your chapter. Thank you.